Hi, I'm Kevin Kurtz. I'm the VP of Engineering for Quadrant Solutions. We're going to talk about radial rings. So we can do a centered radial ring. That's the direction of anisotropy actually follows the radial pattern all the way around. Until recently that wasn't possible, and the reason for this is when you press the NdFeB together, it has to be pressed under the magnetic field in the direction of anisotropy, the direction that you're going to magnetize the magnet. So typically that's one direction. If we press these into a ring shape and we want a radial ring, we want that direction to follow around the arc, we actually have to press them under a radial field, which is very challenging. So what we do is we run this field through a center shaft or on the outside while they're pressed in a ring shape mold. This does have some limitations. We have to get that magnetizing stuff inside the ring, which means the minimum ID we can make these is 25 millimeters because we have to fit that magnetization stuff in the center there. That allows us to create the magnetic field around them. So they're about an inch minimum on the ID. The OD can't be over 60 millimeters, and that's because when we're centering, we'll actually crack and break these. So we have very specific measurement requirements for these, but it allows us to create a continuous ring of a magnet. Before, we had to use different arc segments and glue them together, which was a little less efficient. They have a single direction of anisotropy through the center of the arc. These follow us around, which means we don't lose the cosine of that angle of the magnetic power as we go into each pole. So if we create a north-south pattern on the outside of this rings, it creates a much more efficient motor as long as we can use those specific dimensions that we need. These can be used for magnetic bearings, for torque couplings. They can be used inside the motors as a rotor and have a lot more power than the segmented arcs, because as we flow across that arc, we actually lose the direction of anisotropy is up and down on those. We lose the sign of the angle of what's happening of that power as we go around. That doesn't happen with a radial arc because it gets its full magnetic induction all the way around the circle. We have engineering services to help customize these magnets. They can be made to your shape, size within the boundary conditions we talked before. We can ramp up very quickly. We mass produce these. We can make millions and millions of them at a time, or small sample quantities if you need. There are some tooling fees involved with these, unlike most sample magnets, because of those custom molds and the centering setup. We can help do engineering, design, FEA, any simulation needs, full engineering support, material selection for coercivity. If you're using these in a motor application as a rotor, you're going to have opposing fields on them, so we want to make sure they don't demagnetize. We can help you select the right coercivity material to stay magnetized in your temperature and opposing field requirements.